In the beginning, there was the Big Bang. And there was the expansion of the universe and the formation of the fundamental forces. There was the war of attrition between matter and antimatter. The cooling of the universe allowed for the formation of hydrogen and helium atoms. These atoms came together into clouds and formed galaxies, and eventually stars, the first generation of stars. Through the fusion and supernova processes, heavier elements were created with a second generation of stars, this time with planets. On at least one of those planets, single-celled life came into existence. That life then grew and differentiated itself into plants and animals. Life going from the oceans to the land. The Darwinian process of evolution to mammals, to primates. The advent of consciousness. The universe is now self-aware, through us at least. That consciousness is now engineering itself and the world around it to its liking. I would argue the next step in this grand scale of evolution would be for life to become multiplanetary, for the light of consciousness to spread. So here we are. We're currently faced with this critical branch point in our history. Do we remain locked to this single planet, or do we spread? Do we wait around for some natural or artificial extinction event to occur on this planet? Because we're quite vulnerable here. Our eggs are all in one basket. Take asteroids, for example. I know they're hyped up in the media a lot, but the fact is that we've only mapped about a quarter of the civilization-ending sized asteroids that pass by the Earth's orbit. A quarter. The amount of money the world spends on finding and tracking and following these asteroids is equivalent to what the annual salary is of the 3rd Division football team in my local area. Just let that thought explode in your mind. There has been a disparity between our social development and our technological development for as long as we've existed, really, as humans. For several thousand years, at least, we have been systematically selecting our fittest to go to war, to die. We've been ruining our genetic pool. Take World War II, for example. The average acuity of a person's eye in the UK dropped significantly after World War II. Thankfully, now we've got laser eye surgery. Take the brain, for example. As we all know, the brain grew rapidly at the beginning of humanity. The growth of the neocortex exploded over a couple of million years. But since the invention of agriculture and civilization, our brains have actually been shrinking. We no longer really need to think to survive. Civilization just carries us along. Thankfully, this is beginning to reverse, it looks like. With the rise of smartphones and the internet, a person today is exposed to and processes about an order of magnitude more high-level information than they did a couple of generations ago. And when you look towards the future, to what our capabilities will be like with genetic engineering, bioengineering, integration of biology and technology, it looks like we will eventually be able to engineer ourselves, not only physically, but mentally. How long will it take for us to reach that point of development? What are the chances that we're going to wipe ourselves out before that ever happens? Or at least put ourselves into another dark age? The current state of humanity, the way I see it, is like this. The planet we live on is finite, and the resources we share on it are limited. Pushing forward green technologies, bringing in strict regulations, policing the way we use our resources will slow our eventual collapse. But don't be fooled into believing it is a solution to the problems we face if we intend to remain here. Knowledge traverses a very tenuous thread. There have been many points in the past where amazing technological advancements have been lost. I mean, take 16th century China. They were the world superpower in terms of their navy. You'd think it'd be the West somewhere, but not even close. The Chinese were several hundred years ahead of the West in ship technologies. They had 500-foot-long vessels, multiple masts, multiple bulkheads. We in the West never had anything more than about 100 feet at the time. But then there was a change in leadership in China. The emperor decided to take on a new philosophy, Confucianism, and essentially the Chinese closed in on themselves. They had these enormous vessels exploring the world, but they called them back. They made it as far as the South Africa, nearly across the Cape of Good Hope. But they called their vessels back. They did not want to associate themselves with the outside world. They didn't want to lose their purity. And the emperor ordered that all of these ships, these ocean-going ships, be burned. Hundreds of years of technology and innovation were lost within a generation. A couple of decades after China burnt their ships, the Portuguese made their way around Africa and found China. And that dramatically impacted the future of the Chinese civilization at the time. Today, well, in the 70s, we stopped sending people to the moon. We almost immediately lost the capability of doing it. We lost the technology to build a Saturn V rocket. Now the US is barely capable of sending people into low Earth orbit. It's sort of a repeat in history here almost. Let's see what happens. I think we need to spread as soon as possible. We need to up our chances. We need to spread our eggs out of the one basket to hopefully allow for the technological advances to bring our social development up in the coming decades, maybe centuries. But where do we go? Mars. Mars is the next logical step for humanity. The moon to Mars is what Greenland was to North America in the previous age of exploration. The moon simply does not have the resources required to sustain a technological civilization. Mars does. Even for technological development, the moon makes no sense. You'd send your hardware there to test it before you go to Mars. The moon is so different from Mars that we'd be better off using high-altitude deserts on Earth or Arctic deserts on Earth to test our hardware. It'd be a lot cheaper too. A year ago, I was the crew commander on a Astronauts on Mars expedition in collaboration with NASA, the European Space Agency, and a number of other academic and scientific institutes, probably 24 institutes in total. And we conducted, a group of 7 of us, conducted about 24 experiments in collaboration with these groups. Everything from rover field testing to psychological studies. People on Mars are going to need to be far more independent than, say, astronauts on the International Space Station because of the delay in communications between Earth and Mars. That's anywhere between 3 and 21 minutes, depending on where they are in their orbits, the Earth and Mars. So what happens if there's a radio failure in a spacesuit? How do you communicate whilst you're conducting fieldwork in an effective way? What happens if someone's injured whilst conducting fieldwork? How do you get them back to the habitat module safely? How do you even pick up somebody wearing a spacesuit in a safe way? Say there's a medical emergency that none of the astronauts is capable of dealing with. How do you optimize the communications between a specialist on Earth and those astronauts on Mars? There are thousands of questions like these that need to be considered, and this was one of the things we were working on. As I said, Mars has all of the resources required for civilization, but there are many aspects to this. One of the pieces of hardware we were developing was something that would extract hydrogen from soil and react it with carbon dioxide, which is the main constituent of the Martian atmosphere, to create a methane propellant for rockets, i.e., traveling to Mars, you don't need to carry your return fuel with you there. You can generate it on the surface of Mars. Radiation. Now, there are a number of hurdles, let's say, that are hyped up in the media and by many scientific institutes interested in their research that I want to address quickly. Radiation being one. It's often cited that an astronaut going to Mars on a conventional 3-year round trip, that's 6 months there, 18 months on the surface, 6 months back, would be exposed to their lifetime allowable dosage of radiation in that single trip. The thing is, what is often forgotten is that that allowable dosage is only about, is the equivalent of increasing their chances of getting cancer by about 3% at some point later in their life. For a healthy person, that's from 20% to 23%. It's not a major thing. For example, smokers on Earth. If you work the numbers, it is actually, radiologically speaking, healthier for somebody to live on Mars than it is to smoke on Earth. A smoker on Earth is exposed to about 60% more radiation than a person on Mars would be. One of the projects I was working on was how do you mitigate against these radiation issues? Something I proposed was redistributing the internal layout of the habitat module such that, on average, at any point, you've got bulk material between you and the radiation. Just tailoring existing bulk, putting it in the right places, we were able to reduce the radiation dosage by about 20%. There's no single solution to this radiation problem just yet, but with ideas like this, it becomes a non-issue. Gravity. So Mars has a gravity that is 38% that of the Earth's. And astronauts have been looking at the health effects, bone atrophy, muscle atrophy in microgravity. That's zero gravity, essentially. How do we deal with this? How do we deal with this gravity differential? What consequences are there? We don't know. We know about microgravity, but we don't know about 38% gravity. Essentially, we're going to need to go to Mars to find out what actually happens. What are the subtle long-term health effects associated with a lower gravity? One way to mitigate against this would be to transition from Earth gravity to Mars gravity over that 6-month journey by creating an artificial gravity, spinning the spacecraft, essentially creating a centrifugal force that would simulate 1g going to 0.38 g over that 6-month journey. Power. It's remarkable the ideas people are coming up with. We need nuclear power plants. A significant figure at NASA told me we need to invent fusion power before we go to Mars. And it just blows my mind because a simple back-of-the-envelope calculation will show you that, let's say, the average US household, the energy chewed up by that, how many solar panels would you need on Mars? What square footage would you need? Well, it's equivalent to about 18 foot by 18 foot to power the equivalent of a US household on Mars. You need to scale that up, of course, for a Mars habitat, but it's just not a major issue. It's well within our capabilities. Anyway, we need to put things into perspective. To generate a Mars program, to build the hardware, to send it to Mars, to establish a permanent presence on Mars, would require the equivalent of a few weeks' worth of the US defense spending. It's not a lack of technology that is stopping us from going to Mars. It is our short-sightedness as a species. There will always be more immediate concerns that distract us from what lies further ahead. We're always preoccupied with what's going on today, and it's forgotten next week. We need to find a balance between dealing with our near-term and our long-term problems. And with the world spending 7 times more on cosmetic makeup than it does on its space agencies, with the US set to spend 10 times more on nuclear weapons over the coming decade than it will on space exploration. With the UK government spending the equivalent of what it does on gastric band surgery through the NHS, it spends that much on its space activities. I don't know really what to say, how to end this, but I'd like to implore you to really consider our future, to focus a little bit more on the long term, because we are just too preoccupied with what's going on today and tomorrow. Thank you.